Hey everybody, it's Charles Yeomans. Been a while, and it's good to at least sort of see everybody here. I know we've been going a few months here without having had a chat. We always were like planning to, but something interfered. So to avoid a having something going here in which we had to wait for some other guy like Viasat has been saying, yeah, we're going to get a guy. And then Al-Hamrani, same thing. So we just want to get going and have at least a short one here in which I can catch everybody up on where we are, tell you about developments in the company, and just a quick brief. So we'll set up another one in a month, I think, to catch everybody up on a little more detail, and we'll also do another. We'll bring in like either Viasat, Al-Hamrani, Ericsson, somebody, one of our partner firms, to talk about kind of what we're doing with them and how they see our stuff. So with that, so I've got a little deck. Sorry, I've got a little deck I can talk through here. I'm making the general assumption that most folks are pretty familiar with, they're on this or somewhat at least familiar with Neurpac, which is, the product we've been working on mostly. But then I'm going to give a quick grounder on that, and I'll also talk a little about PCM, the new Gen AI we have, and also then we'll give you a chance to ask some questions. So I'm going to try to zip through this presentation and then open it for questions, since given it's a pretty short time frame. So with that, I'm going to share the screen here and go here. Okay, so sorry about that. So first, I just want to let you know this is a deck that I've been using with some of the institutional investors and all that. So it's got, I've trimmed it down a little, but it kind of gives you a sense of what I'm saying to institutional guys. So basically what we're addressing is the fact that there's a ton of data, especially IoT data, that's getting bigger and bigger all the time. And it's very, very difficult to deal with it. And so as a consequence of that, like McKinsey and some others say, basically maybe 1% of it is actually looked at and used for any kind of analysis, which means, in effect, that a lot of it just gets generated without any reason to be generated. It isn't that people don't want to read it and do something with it. It's just they can't. It's either too much for humans to look at, it's too much to send, and it really needs something AI to look at it and be able to comprehend an entire thing at a time. So and then sort of why doesn't anything now work for that stuff? Well, one is the compression just doesn't work on IoT stuff, without batching, which means it's taking on a lot of latency. Nobody wants that. And so what do? Right now, unless you have Neurpac, you don't do anything. You just sort of deal with the fact that almost none of the data can go anywhere. And the other big thing is that LLMs and the edge AI, like, small language models, agents, they don't adapt. They don't learn anything. And they use a ton of power. And I don't think anybody's going to be surprised to hear, me say that, yeah, the hallucinations are a big problem. So anyway, with all that, here, what do we do? First is I want to address this Neurpac, which is our real released, heavy duty product that is basically what it does is it reduces the size of IoT or any other datagram. Actually, we're starting to deal with bigger ones now too, significantly by swapping out the contents for code words. So a big file or even a small file can just get the contents of it can be replaced with little representations of patterns in that file. And that's what we're doing. And we do it in a few microseconds, which means that given we do about 75% reduction, and since we do it in essentially real time, we can usually quadruple the amount of data that can travel through a given transmission, so a pipe. So what we're really talking about here is something that's dramatic, that has the potential to impact how data is structured in a basic way. So it's a foundational technology. And so it's important to know that this technology has been worked on and is now a real product that has been released and is in use, and customers are paying for it and all that stuff. Big point. Second thing we are working on, and this one is not that, this one is still very much an R&D project, is what we call the PCM, or the Persistent Cognitive Machine. And sorry, it is not what all other, Gen AI is, which is it doesn't use a neural net. It doesn't use transformers, which is a radical thing. And instead, it uses geometry. Now, I'm going to show you a little illustration, a little thing that shows you how that works. But the cool things about it are it learns. Instead of its training, it's learning. And it learns and it shapes its own internal cognitive understanding of things on the basis of this learning. So it's really, this is like a radical thing. And I can't tell you how big a deal it is. And it does work. We have it working. Now, I don't want to tell you that it's ready. It's a product that we're rolling it out anytime soon. It's not, but it is a really cool thing, and it does work. And part of the way what it does is it, will, because of the way it works, it's not a statistical prediction thing like an LLM. It uses this cognitive geometry instead, which will probably, and we need to prove this, produce significantly fewer hallucinations. It would also, because it's way more compact than an LLM, they'll use dramatically less computational power, and therefore will cost a lot less to run. Another cool thing is these things talk to each other. So you could have PCM instances, one in, say, the command center of a ship, a Navy ship, and another one, and it talks to one on an aircraft, one on another ship, one on, on a missile, whatever. So that is called federating. So when they talk to each other, they are passing along knowledge that they've learned. And the last thing to mention, this a really significant point in this, is that it's really, really compact. And so it's using this, I got to tell you, it's this idea that, is borrowed from general relativity theory that uses thousands of dimensions in this geometry. And so what it's doing then is it packs in a lot of information in a super dense way. So even a big organization over a long period of time probably won't exceed 250 gigabytes in their total geometry. Now, again, this is all new stuff, and we're filing patents like there's no tomorrow. We need to, because this could change everything. That being said, it's still very much an R&D project. So just to mention on Neurpac, so where is it now? Well, Al Hamrani is a partner of ours in Saudi Arabia. It's the biggest fintech in Saudi Arabia. We are big time partners with them, have been to visit them. They are, going to be resellers of ours. They're already using the technology. we get big time reduction. They're thrilled, and they think, they can sell a lot of our stuff. Another is Viasat, big partner of ours. They are using it for an oil and gas customer. We think that this could really expand. They've been waiting for this new version of the tech to come out that will come out in November. I'll tell you about that. And then finally on the Space Force, Link 16, we're working closely with L3Harris on this. L3Harris is excited about it because we can be transformative to how the baseline, the most important data link used by the US military and allied militaries, which is Link 16, which is really, really slow, we can dramatically increase the speed of it. In real life, it'll probably be more like 4 times because you got all these considerations, but net it's dramatic in its potential impact. So this is the difference between a neural net and how the PCM works. So on the left, you're seeing how a neural net works, which is you've got a bajillion nodes, and they're all talking to each other and all providing different weights. That is to say, what the training is doing is deciding what weight to assign each of those nodes. And that is the essence of how LLMs work. And the thing about it is you're not teaching it data, information that says this dog is brown. You're not. You're giving it concepts. And that's what the power of this is. It's not just a database. The same you could say is true for the PCM. The PCM, as you see from this, is associating a bunch of things that are close. That is to say in the yellow, you had dogs and cats. And okay, those are pretty close to each other. And there's a direct connection between them, and they're related. And so we're confident about that association, whereas maybe the light blue is nuclear physics. And so the idea of associating dogs and cats with nuclear physics seems like a very strange idea, and it may not actually work. And so that gives it high curvature in this geometry, and means that it needs to get more attention, more computing, more paying attention to it. And maybe it's true and maybe it isn't. But the fact that it calls attention to the fact that these things are probably not related means that we can avoid a lot of the hallucinations that occur. Another thing about it is when it learns something, it changes this geometry. Some of these little dots that are representing thoughts are, going to be modified in accordance with why you would. Will actually, if it learns something, put it this way, if it learns something, yes, it turns out there was a really smart dog who was a nuclear physicist. And so there is some possibility, but it's generally not going to be the case. So at any rate, so the net is you have this overall completely different approach to how you think about generative AI. Ours is way more efficient, it learns, and it can do things that neural nets cannot. So this means, in effect, that you've got something really, really new in both these cases, in both these technologies. These are foundational technologies. So with Neurpac, it's a real thing, and so you can put it out there. And we have a new version. So most of the demand we've had, so we have a SaaS that was released earlier this year. We are now working hard on a new wrapper for Neurpac. It's the same core technology, but it's got a new way of deploying it that will allow companies, which is what they want, to deploy it on their own premise. So that means that they can load it into, like Ericsson could load it into their gateway, and they also could put it into their cloud, or somebody else can put it in their cloud. So it's all basically on the customer premise. that is where the demand is. And so that's where we're going. So here's some examples. So smart meters, like for oil, for gas and electricity and so forth, those, we see as there's lots of possibilities there. And we think the pricing is going to look like 5 cents a month. And the first one we're talking to wants to put 8 million units on it. That's a $5 million deal. There is also the point of sale network, 300,000 devices at $1 gig a month, times 300,000 devices, and you charge 50 cents a gig. That's a couple $1 million bucks, close. Now the PCM is probably going to look like the way agents are charged for. So, an enterprise would probably rent it for us from $500,000 to a couple $1 million a year. Depends how big they are and all that. Bigger ones probably even more. And the edge deployments are going to look like, say you had one oil field, it might be 5,000, 10,000, 15 a month. So in the PCM, we're working on that. Should come out. We think we'll have a beta by next year, by first half of next year, and we're hoping to release it by the end of next year. It's a pretty heavy project, and we're going to need money to do it. So anyway, why is this a big deal right now? Well, because Neurpac, there's a huge amount of data coming out, right? And you can calculate it a lot of different ways, but it's probably the capacity of networks to move the data that's getting generated is something in the range of like 4 to 7%. And you see the quote from MIT's study. What is the barrier for adoption of AI? It is learning. It's the ability to learn. And so you add all these things up, and the key thing here, more important than any aspect of PCM, and there's a lot of important ones, the most important is the fact that it can remember things, and not just remember them like you hear about, like ChatGPT and Claude. They can go back and search on other interactions you've had. That's not learning. That is database enhancing. It's a different thing. We're changing the internals of the PCM's geometry as it learns things, and that's different than going back and referring to an earlier conversation and looking at that fact, those explicit facts. So, I just wanted to mention this. So I think there's actually a new one now. We have boatloads of awards. Every time we come up for an award, it seems like we're going to win it. I mean, it's just unbelievable because people who really dig in and understand our tech see it for what it is, which is, this is, tremendous. And I got to tell you, all these are based on Neurpac. We haven't even talked, or competed for things related to PCM yet. And this just gives you a sense. So we're over 300 patents, including the pending ones. And actually these numbers are even now old because we keep banging out patents for PCM. So just in terms of where we sit, so direct competitors to Neurpac, well, there really aren't any. I mean, you could say compression, but compression is not going to be able to, you're not going to be able to search, and it won't work on individual IoT datagrams, the typical ones. It just isn't any comparison, and the speed of them are, I can't say this absolutely, but I can say in general terms, 400 times faster than compression. So you put it over the side and you say, it's more than just a comparison with that. It's really a restructure of how data works, and how it's structured in a really, really basic way. And that's the miracle of it. It's an amazing thing. So in the PCM, sure, there's lots of competitors, but they're all using neural net transformers. it's fundamentally different. And so, sure, we're interested. We would nominally compete with them, but we don't see it as like, head to head. We really don't. So we're getting calls from some pretty big time companies about PCM. They're desperate for something that solves the big problems that you have. Just really quickly on the organization. So we've got some really senior people here. These guys know what they're doing. This isn't guys just, dropped out of Stanford and trying to figure out how to do all this stuff. Everybody here has done it before. So we're, I would say this is really an A+ organization. So just to sum up quickly, we are really a foundational, transformational couple of technologies that are really going to change the world, we think. Now, there's others that I haven't brought up here, like Neurcom and Neurcom 2, but these are the two. These are our stars. So anyway, I just wanted to give everybody a chance to understand all that, and then we can move on and talk about. We can take in some questions. So without further ado, why don't you give me a question?
Great, Charles. So thank you for the presentation. And as a reminder to all of those that are watching, you can drop in. We can't bring people on and add audio and all that stuff, but you can drop in any questions that you have in the comment section on the chat on the right. But just going top to bottom here, Charles. So the first question that came in, you've mentioned Kennedy is next month in both August and September. Do you have a current prediction or updated prediction for that?
Yep. So we are still on for doing that on October 1. That is set. We have the Navy is so excited about it that they anticipate that we'll need at least 2, maybe even 3 sessions, because they expect to fill the room multiple times. Because you think about it. So I got to give everybody some background here. So we went and talked to the Navy, to this outfit, part of the Navy that does kind of their R&D and so forth. It's called NIWC PAC. So NIWC is, had this vision that they call the command center of the future forever. And they want to know, how can we make this real? So we are going to go to them, and we anticipate that we'll be able to give them, here is Kennedy, that is to say the USS Kennedy's command center of the future for real. And they'll be able to interact with it, test it, use it, do all that stuff. And they're like, I got to tell you, I mean, we have the attention of a lot of senior people. And if anybody wants to see what that's all about, you can go Google Sea Strike 2043, Sea Strike 2043, and you'll see a video that shows what that's about.
Great. A couple questions coming in from that. So any updates, and I know you spoke about it a little bit here, but updates on DoD contracts, any hints of what might happen?
So we're in, I mean, I got a bunch. We will be, we're going to be getting, I mean, I can't ever say anything for sure, right? But I'm feeling good about this. I'm feeling very good about where we are. We're having, like yesterday, we had a call with NASA, very senior guys at NASA. They desperately, they would love to get PCM. We got to get it further down the road for them, but they love Neurpac. Think about what NASA's doing. They have something the power of a 20-watt light bulb trying to send data from Pluto. And we're trying to receive it here, right? I mean, guess what? An awful lot of it doesn't make it. And so if you can pack 4 times more data in that same signal, I mean, and do it without using a lot of power, which is a huge problem for those things, they would love to get something like that. They were over the top. So that's just one example. We also have conversations. I'm meeting with some generals next week from the Air Force. We have conversations with various Navy admirals. We're talking to the Missile Defense Agency. I mean, I'm confident that things will pop. And it's just, we're going a different route. We're also doing, they apply for things, but that's a low percentage game. We want to get the inside baseball game going.
Makes sense. Question from Ed here. CF Raise, is that opening this week? What is that looking like?
I think it's going to open next week. We've got we're in the final stages. We took for freaking ever, but we're through all the bad that isn't bad. It's just painful because it took so long. But at any rate, we're through all that stuff. Now it's just a few bits of paperwork left. So maybe late this week, most likely next week. But I would tell everybody there's no downside in reserving your shares. If you reserve shares, it's just a reservation. You don't have to do it. You're not committing. So I'm just saying, all you're doing is getting yourself in a position that if you do it, you get bonus shares. That's it. So don't hesitate to do that. Go ahead.
Right. I think functionally you make the reservation, and then when the campaign does go live, you can go ahead and complete that or confirm the investment. So nothing happens technically at the reservation piece. So what are the biggest obstacles to more widespread adoption of the technology?
So I think that once we get the on-prem, the version that goes into somebody's private cloud or somebody's gateway or somebody's whatever, then the constraints that we've faced up to now are gone. And I could see that going hard and fast, so we come out with the end of November. We'll sign up some stuff. I don't know if we'll get revenue out of it this year, but I think, Q1, things will start to really pop. And you're going to see some action. So I don't know what it could be that constrains us there, because it's a huge, huge market, hundreds of billions. Now in PCM, okay, so the CEO of OpenAI says the most important thing is learning. And we have an AI that learns. Well, guess what? Is that valuable? What do you think? I leave it to you.
Great. And then a question from Jim here. What are the issues to iron out before Q2 2026 specific quarter?
So I think that's a good question. I think that the big things are going to be getting through PCM, getting PCM into, so two things. One, we got to start knocking down some revenue, which I think we're going to start doing here in a serious way when we get Neurpac on-prem released. And then the other big thing is getting PCM knocked into shape. We have like 4 physicists and a mathematician all cranking away on it. And these are high-level people. These are people that, nuclear physicists and general relativity astrophysicists and stuff that are doing this stuff. I'm confident that we're getting there, but it's we got to keep working on it, and we got to hold off, like the calls we're getting from, I got to tell you, every AI company, every hyperscaler, everybody's like getting wind that this is there. And part of it's because we're getting a bunch of patents really, granted. So go ahead.
Great question from Chris, aka Beermeister, but it's just a funny nickname I think that was put in here. But have you talked to anyone at Space Systems Command? I would think the remote sensing office would benefit greatly from Neurpac.
I haven't, at least not lately. I think we did talk to them a couple of years ago, but we weren't really ready. We're ready now, though. And it's just a question of capacity, right? It's like how many people we have and how many opportunities there are. There's so many opportunities that I just can't tell you. It's huge. And so I can't tell you we're going to, I can just say Space Systems Command makes a lot of sense. They're a little slower moving than, like, for instance, the SDA. this space development agency, but where we've had a contract before. But I really think we're in a position now we're going to be able to crank out and really make this into something that is going to be really interesting, not only to Space System Command, but also to SDA and many others, because Neurpac on-prem is what they want. It's what everybody wants.
Great. And I know we're a few minutes over here, but we do have a couple more questions. So if anybody wants to stick around, it's great. But how do you ensure that licensees pay for your software after the license expires? Once it's out of your hands, they can use software indefinitely.
Well, they're based on time, right? I mean, so it's like the whole thing with Mission Impossible, right? After whatever, a year or 2 years, whatever their license is. So and then they have to get a new code, just like you do, with a lot of kinds of software, right? You got to put in your code, and then boom, you're off to the races. You got to buy the code, of course. That's the idea.
Got it. I think you talked a little bit on your presentation, but from a competitor perspective, the competitive landscape, can you recap a little bit of that?
Yeah. So we still haven't run into a direct competitor for Neurpac, unless somebody's willing to take latency by batching, which means waiting while you gather up a bunch of these little messages. You can pack enough together that you can use compression on it. But most guys don't want to do that. And so, there really isn't a direct competitor to Neurpac. Now, PCM, obviously, it's every big AI company, right? But at the same time, it is and it isn't. It's a really different thing. And I don't think, I would say everybody needs to think about this. What is it that if you were an AI company, if you're OpenAI, you're Anthropic or something, or you're Google, what is it when you look at this and you understand what's going on with with PCM, what would your view be if somebody else gets it and you don't have it? And I just leave that in your court.
Great.
So, unfortunately, I got another call I got to jump on. I apologize for that, but I wish I could stick.
No problem. Well, any other questions, and you guys can leave it on the starters.com/AtomBeam page. But Charles, thank you so much for the time. Everybody have a great day.
Yeah, I'm sorry. Sorry I had to scoot, guys. But we'll set up another one, I promise, in about a month. All right.
Sounds
okay.
Great.
Thanks, everybody. Take care. Bye.